Hello, everyone, and welcome back to Teach Astronomy. Happy Monday, everybody. My name's Victoria, but you can call me Vicky. And today we're going to be doing book chat. I see that there's already several people here. I hope you guys are excited. We're starting a new book today since we finished the last one a couple weeks ago and did our author chat last week, which if you missed the author chat, I believe it's still on the Twitch page, but it's also archived on our YouTube channel. So that'll be there forever if you ever are interested in rewatching that. I see some people are already here. Greetings from North Carolina, from Paris, France. That's so cool. I heard is it snowing near you guys? I heard some people are getting snow over in the UK today. I know some people in New Jersey got snow last night and like the east coast of the United States. Hope everyone's weather isn't too annoying to have to deal with. Oh, from Belgium, lots of snow there. Yeah, I could imagine. Student McLeod, we did start the this past Friday stream at 8 because we had some scheduling issues and we didn't realize we had those scheduling issues until Thursday. So definitely a possibility you might have missed that. Sorry that we couldn't give you guys as much of a notification on that one, but it should go back to our regular schedule of starting at 10 a.m. Pacific Standard Time in the future. It was just an issue with my availability with this computer, essentially. My partner teaches and he needs to use the computer as well, and they had a midterm last week, so lots of questions from students. but yeah, so it'll go back to regular time. But thank you guys all for joining me here today. So like I said, we're going to be starting Dreams of Other Worlds, and I think we are going to totally lost my train of thought. Oh, I was going to say I think we're just going to be doing the introduction today because the introduction's actually like 13 pages long. And this book is large. And also the print in this book is a lot smaller. It's hard to see. There you go. It's a lot smaller than Einstein's Monsters. So, and like the typeface is just closer together, so it's a lot denser. So I'm not sure. Normally with Einstein's Monsters, I could get through about 13 pages per hour. So most of the chapters were somewhere between 25 and 30 pages, so we could do a chapter in 2 hours easy. This one, I'm not sure. So we're just going to do the intro today. It'll probably only be like an hour or so, but we'll chat about the book. We'll chat about whatever we want to chat about. And yeah, have a good time. So first of all, I just wanted to say that, so this Dreams of Other Worlds is written by, it's about the amazing story of unmanned space exploration, as it says here, and it's written by Chris Impey, our lovely Chris, and also Holly Henry, who is, she is a professor of English at California State University, San Bernardino. So I wanted to show you guys a picture of her since we don't know her the way we know Chris. Let's see. She is right here. Okay, let me show you guys. Bring up my Chrome, please. There it is. That's Holly Henry. It's a very small picture, but so she wanted to find a list of her books. Let's see. Holly Henry books, because she's written other stuff too. Oh, that's Rate My Professors. No, we don't want that. Okay, I guess she's only written this one, but it was mentioned on the back of the book too. Virginia Woolf and the Study of Nature. Oh no, I guess there's multiple. Because on the back of this book it says Virginia Woolf and the Discourse of Science, the Aesthetics of Astronomy. So I guess she's done a bit of a series on Virginia Woolf and science, so like the intersection between the two. So it seems interesting. It's always nice to have an English professor to check your spelling and punctuation, definitely. Yeah, I did my minor in creative writing, so tangentially English, and yeah, we're always good to have around for that kind of thing. But yeah, so this is the book. And this is the, it says it's the revised and updated edition. So if you guys are following along, I have a copyright 2013 issue if there are any things that might be different. If you have an older version, I'm not sure. Some things, they always update science books when things, are discovered. So yeah, and like new things happen. So I guess we shall just jump right into it. So, introduction. Let me see how I'm gonna set this up. Do you guys, this is a question. I want to see what you guys think. How do you guys feel about folding the pages back, or the front of the book back on soft cover books, on paperbacks? I know some people get really upset by that. That and like dog-earing pages. I don't really dog-ear pages. Sometimes I do find myself doing this thing though. I'm going to try not to, because it's a nice book. But I might a little bit. You fold them back too? Yeah. Yeah, it's like you don't want to mess up the book, but it is like a lot easier to hold. All right, let's start this. Introduction. Someone who missed the late part of the 20th century, perhaps by being in a coma or a deep sleep, or by being marooned on a desert island, would have many adjustments to make upon rejoining civilization. The largest would probably be the galloping progress in computers and telecommunications and information technology. But if their attention turned to astronomy, they would also be amazed by what had been learned in the interim. In the last third of the century, Mars turned from a pale red disk as seen through a telescope to a planet with ancient lake beds and subterranean glaciers. The outer solar system went from being frigid and uninteresting real estate to being a place with as many as a dozen potentially habitable worlds. They would be greeted by a cavalcade. I've never heard that word before. Cavalcade. They would be greeted by a cavalcade of exoplanets projecting to billions across the Milky Way galaxy. The familiar view of the sky would now be augmented by images spanning the entire electromagnetic spectrum, revealing brown dwarfs and black holes and other exotic worlds. Finally, they would encounter a cosmic horizon, or limit to their vision, that had been pushed back to within an iota of the Big Bang, and they would be faced with the prospect that the visible universe might be one among many universes. This book is a story of those discoveries, made by planetary probes and space missions over the past 40 years. The word world means age of man in the old Germanic languages, and that proximate perspective took centuries to expand into a universe filled with galaxies and stars and their attendant planets. The missions at the heart of this narrative have not only transformed our view of the physical universe, they've also become embedded in culture and inspired the imagination. This book is also a story about that relationship. But people were dreaming of other worlds long before the space program and modern astronomy. Almost nothing written by Anaxagoras has survived, so we can only imagine his dreams. He was born around 500 BC in Clazomene in Iona, a bustling port city on the coast of present-day Turkey. Before he moved to Athens, he helped to make it the intellectual center of the ancient world. And long before he was sentenced to death for his heretical ideas, we can visualize him as an intense and austere young man. Anecdotes suggest someone who was far removed from the concerns of everyday life. He believed that the opportunity to understand the universe was the fundamental reason why it was better to be born than to not exist. Anaxagoras' mind was crowded with ideas. Philosophy is based on abstraction. The power to manipulate concepts and retain aspects of the physical world in your head. He believed that the sun was a mass of fiery metal, that the moon was made of rock like the earth and did not emit its own light, and that the stars were fiery stones. He offered physical explanations for eclipses, for the solstices and the motions of the stars, and for the formation of comets. He thought the Milky Way represented the combined light of countless stars. We imagine him standing on the rocky Ionian shore at night, with starlight glittering on dark water, gazing up into the sky and sensing the vastness of the celestial vault. The dreams of such a powerful and original thinker were probably suffused with the imagery of other worlds. This is speculation. As with most of the Greek philosophers, and especially the pre-Socratics, very little of their writing has come down to us unaltered. Typically, there are only isolated fragments and commentaries, sometimes by contemporaries and often written centuries later. Each historical interpreter added their own predilections and biases. The result is a few of the original ideas seen through a gauzy veil. Modern scholars pore over the shards and often come up with strikingly different interpretations. Anaxagoras thought that the original state of the cosmos was undifferentiated, but contained all of its eventual constituents. The cosmos was not limited in extent, and it was set in motion by the action of mind. Out of the swirling, rotating mixture, the ingredients for material objects like the Earth, Sun, Moon, and planets separated. Although the nature of the animating agent is not clear from his writings, Anaxagoras was the first to devise a purely mechanical and natural explanation for the cosmos, without any reference to gods or divine intervention. His theory sets no limit to the scale of this process, so there can be worlds within worlds, without end, either large or small. A case can be made that he believed that our world system is not unique, but is one of many formed out of the initial and limitless mass of ingredients. Radical ideas often come with a price. For daring to suggest that the sun was larger than the Peloponnese Peninsula, Anaxagoras was charged with impiety. He avoided the death penalty by going into exile in Asia Minor, where he spent the remainder of his life. Pluralism, the idea of a multiplicity of worlds, including the possibility that some of them harbor life, had antecedents in work by Anaximander and Anaximenes. Lots of Anaxa. I hope I'm saying that right. I might be butchering it. But had antecedents in work by Anaximander and Anaximenes, and in speculation passed down by the Pythagorean school. But Anaxagoras was the first to embed the idea in a sophisticated and fully fledged cosmology. By the time of the early atomists, Leucippus, where I didn't expect so many ancient civilization-esque names today. Okay. By the time of the early atomists, Leucippus and Democritus, plurality of world was a natural and inevitable consequence of their physics. There were not just other worlds in space, but infinite worlds, some like this world and some utterly unlike it. It was a startling conjecture. The next, thank you for the follow. Shin974, thank you so much. Welcome to the TeachAstronomy family. Thanks for struggling through these names with me. The next 2,000 years saw the idea of the plurality of worlds ebb and flow, as different philosophical arguments were presented and were molded to accommodate Christian theology. The pluralist position was countered by the arguments of Plato, and particularly Aristotle, who held that the earth was unique, and so there could be no other system of worlds. European cultures were not alone in developing the idea of plurality of worlds. Babylonians held that the moving planets in the night sky were home to their gods. Hindu and Buddhist traditions assume a multiplicity of worlds with inhabiting intelligences. For example, in one myth, the god Indra says, quote, "I have spoken only of those worlds within this universe. But consider the myriad of universes that exist side by side, each with its own Indra and Brahma, and each with its evolving and dissolving worlds." End quote. In cultures around the world, dreamers' imaginations soared. The Roman poet Cicero and the historian Plutarch wrote about creatures that might live on the moon, and in the 2nd century CE, Lucian of Samosata wrote an extraordinary fantasy about an interplanetary romance. A True Story was intended to... That's the name of it. It's in italics, but it's hard to... intonate italics, but it's called A True Story, was intended to satirize the epic tales of Homer and other travelers, and it began with the advisory that his readers should not believe a single word of it. Lucian and his fellow travelers are deposited by a waterspout onto the moon, where they encounter a bizarre race of humans who ride on the backs of 3-headed birds. The sun, moon, stars, and planets are locales with specific geographies, human inhabitants, and fantastical creatures. This singular work is considered a precursor of modern science fiction. For more than a millennium, it was dangerous in Europe to espouse the idea of fully fledged worlds in space with life on them. Throughout medieval times, the Catholic Church considered it heresy. There was an obvious problem with this position. If God was really omnipotent, why would he create only one world? Thomas Aquinas resolved the issue by saying that although the Creator had the power to create infinite worlds, he had chosen not to do so, and this became official Catholic doctrine and a pronouncement of the Bishop of Paris in 1177. Nicholas of Cusa sorely tested the bounds of this doctrine. In 1440, he produced a book called Of Learned Ignorance, where he proposed that men, animals, and planets lived on the sun, moon, and stars. He further claimed that intelligent and enlightened creatures lived on the sun, while lunatics lived on the moon. It's said that friendship with the Pope shielded him from repercussions, and he went on to become a cardinal. I'm going to pause there for a second. Student McLeod said fake it and move on. Yeah, some of these names I've never heard of. Some of them I know, obviously Aristotle and... Was Ptolemy mentioned? I think he was. And there are others that are oh my. Who are you? Chris needs the little phonetic spellings in parentheses next to the names when they get mentioned the first time. They should. That'd be helpful. Okay. Giordano Bruno was less fortunate. The lapsed Dominican monk had deviated from Catholic orthodoxy in a number of ways, but his espousal of the Copernican system, which displaced the Earth from the center of the universe, brought him extra scrutiny. He believed that the stars were infinite in number, and that each hosted planets and living creatures. Bruno was incarcerated for 7 years before his trial, and was eventually convicted of heresy. A statue in the Campo de Fiorino in Rome marks the place where he was burned at the stake in 1600 as an impertinent and pertinacious heretic. It's not pretentious, it's pertinacious. Pertinacious. To start that sentence over. That was rough. He was burned at the stake in 1600 as an impertinent and pertinacious heretic. Religion had cast an ominous shadow over the idea of the plurality of worlds. The same year Bruno was put to death, a 29-year-old mathematician named Johannes Kepler, an assistant to Tycho Brahe, was working with data that would cement the Copernican model of the solar system. As he published his work on planetary motion in 1609, he dusted off a student dissertation he had written 16 years earlier, where he defended the Copernican idea by imagining how the Earth might look when viewed from the moon. Kepler elaborated on his youthful paper and added a dream narrative to turn it into a sophisticated scientific fantasy. Somnium. Is that the title of something? It's in italics, so I'm assuming it's a title of this scientific fantasy. Kepler was inspired by Lucian and Plutarch's earlier work. But unlike them, and unlike the mystic Bruno, he was a rational scientist who wanted to realistically oh my gosh, I'm so sorry. Ooh. But unlike them, and unlike the mystic Bruno, he was a rational scientist who wanted to realistically envisage space travel and aliens. His narrative is rich with comments on the problems created by acceleration and varying gravity. The geography and geology of the moon are realistically rendered. He even speculates on the effect of the physical environment on lunar creatures, foreshadowing Darwin and Lyell. Kepler had every reason to take refuge in a dream. He was frail and bow-legged, covered in boils, and was cursed with myopia severe enough that he would never see the celestial phenomena he enunciated so elegantly. Somnium was known to Jules Verne and H.G. Wells, and it's a crucial step in the progression towards rational speculation about other worlds. The Copernican Revolution was not a single event. It was a series of realizations over a period of a century that the cozy idea of Earth as a singular place at the center of the universe was wrong. Displacing the Earth into motion around the sun was the first wrenching step, but another was recognizing that the Earth was one of many worlds in space. The Copernican principle is more than just a cosmological model. It's a statement that the Earth is not in any central or favored position in the universe. A heuristic that extends from the work of Copernicus is the principle of mediocrity, which goes much further by supposing that there's nothing special or unusual about the situation of Earth, or by extension, the fact that humans exist on this planet. That is, of course, a central tenet of modern astrobiology, but 400 years ago, it was a radical idea. Did the book get delivered in time? It did. I got this with like 4 other books that Matthew sent me, so I am set for a while. The words, I know, sometimes it's a science book, right? They gotta use big words. You get tongue-tied. Yeah, the Somnium is Kepler's paper, as Katana Steele said. Okay. The scientific revolution recast the debate over the plurality of worlds. Within months of Kepler's dream piece, Galileo pointed his telescope at the moon and affirmed it as a geological world, with topography similar in scale to the Earth. He also showed that Jupiter had orbiting moons and that the Milky Way resolved into points of light that seemed to be more distant versions of the bright stars. The word world was no longer confused with cosmos. It meant a potentially life-bearing planet orbiting the sun, or hypothetically, a distant star. And also that's cosmos spelled with a K. Speculation about life on the moon became routine, almost mundane. However, theology and philosophy still colored the debate in several ways. One theological concept was the principle of plenitude. Everything within God's power must have been realized, so inhabited worlds should be abundant. Another was the strong influence of technology, purpose and direction in nature that implies a creator, who would surely not have gone to the trouble of creating uninhabited worlds. For a long time, scientific arguments could do no more than support the general plausibility of the plurality of worlds. Telescopes could easily track the motion of stars and planets, but gaining a physical understanding was much more challenging. The blurring effect of Earth's atmosphere prevented astronomers from resolving anything smaller than continent-sized surface features on any solar system body other than the moon. Even the nearest stars are 100,000 times farther from us than the size of the solar system. In addition, planets do not emit their own light, so astronomers must gather the 100 million times dimmer light that they reflect from the parent stars. 3 centuries of improvements in telescope design after Galileo yielded only 2 new planets, a dozen or so moons, and no success in detecting worlds beyond the solar system. And so the dreamers held sway. Many of them were grounded in science, so they advanced the Copernican idea that our situation in the universe was not special. One striking work from the beginning of the Age of Enlightenment was Conversations about the Plurality of Worlds by Bernard de Fontenelle, published in 1686. He wrote about intelligent beings inhabiting worlds beyond the Earth, and incorporated the biological argument that their characteristics would be shaped by their environment. Fontenelle also followed Galileo's lead by writing in his native language, French, rather than the scholarly language of Latin, and he was forward-looking in having a female protagonist and explicitly addressing female readers. A much later high watermark was on The Plurality of Habitable Worlds by Camille Flammarion, which reached a wide audience in 1862. By the early 20th century, scientific speculations and fictional accounts of worlds beyond the Earth proliferated, but technology and research weren't able to address such conjectures. There's an unbroken thread between earliest Greek thinkers and the more recent explorations of science fiction writers. Anaxagoras was a visionary, but it would probably have taken his breath away to know that one day we would actually visit other worlds. It's not the end of the introduction, but it's the end of the section, so I'm going to take a break really quick. How is everybody today? How's everyone doing? What's the weather like? What are you up to? What's your plans? Tell me about yourself. Give me a break from reading the very dense material. I'm very excited to read this. I'm really interested in like space flight in general, both manned and unmanned. I think it's really cool. Oh, did you guys see? We'll probably talk about this more on Wednesday for news and stuff. But did you guys see the? If you were watching the Super Bowl, I know we have several international people here. And actually, I don't know if this applies to you guys, but we talked about last week on news that the SpaceX mission, I forget what it's called, but the one that's going to be taking civilians up for the first time to space. They're not like going anywhere specific. They're just going to go into space and come back. They are having a raffle essentially, and they had an advertisement during the Super Bowl yesterday, which if you're not from the US, Super Bowl, you know, it's the big football game of the year, and the ad spots on it are the most expensive television advertising spots, at least, and definitely on like American network television. And they had like a 30-second spot or something saying that, you know, enter here or something. But now I'm thinking about it, and I wonder if, I mean, obviously they're gonna be, because they're saying like anybody could be the fourth person that goes, anyone, and I don't know if it's just to like US citizens. I don't know if there's like legal things that have to, I mean, because they're definitely going to have other things, like you have to be of a certain physical capability and stuff, because like you need to be able to handle, like, if you know, if you have like a heart disease or like a lung problem or something, or like something where if they shot you into space you could have a serious medical issue, they're probably not going to be able to go because they don't want anyone dying up there on their hands. But like, I haven't read the fine print because I don't want to go. But I'm wondering if it's open to like anyone, or if it's just people in the US. I'm not sure. Lots of blue sky in North Carolina in the high 50s. Very nice. Very nice. Send the 50-degree weather up to New Jersey, please. Yeah, the northeast of the U.S. has gotten a lot of snow lately. I know they were digging themselves out again yesterday. All right, I guess we will get back to it. So, let's see. I'm going to move my mic a little bit. There we go. Isaac Newton's Mathematical Principles of Natural Philosophy, a 3-volume masterwork published in 1687, is a landmark in the history of science. Principia, as it is known, laid down the foundations of classical mechanics and gravitation. Tucked away in one of the volumes is the drawing of a cannonball being launched horizontally from a tall mountaintop. This thought experiment sustained the dreams of space travel for nearly 3 centuries. October 4th, 1957, was a pivotal moment in the history of the human race. On that day, a metal sphere, no bigger than a beach ball and no heavier than an adult, was launched into orbit. The world was transfixed, and amateur radio operators monitored Sputnik's steady beep for 3 weeks until its battery expired. Within 2 years, the Soviets had crashed a probe into the moon, the first man-made object to reach another world, and the space age was in full flight. Humans have never been any farther than the moon, but we've sent our robotic sentinels through most of the solar system and slightly beyond. For the universe beyond our backyard in the solar system, we have no direct evidence, and we cannot gather and analyze physical samples. The data are limited to electromagnetic radiation. Newton improved on Galileo's simple spyglass with a design for a reflecting telescope. All research telescopes are now reflectors. In understanding distant worlds, the complement to direct exploration with spacecraft is remote sensing with telescopes. A succession of larger and larger telescopes over the past century have now expanded our horizons and extended the Copernican Revolution. We know that we orbit a middle-aged, middleweight star, one of 400 billion in the Milky Way, which is one of 100 billion galaxies in the observable universe. The pivotal movement in in the remote sensing of distant worlds happened on October 6th, 1995, when Michael Mayer and Didier Queloz announced that they had discovered the first planet beyond the solar system. We're now harvesting Earths from deep space, and our dreams have moved on to the nature of life that might be found there. This book explores how our concepts of distant worlds have been shaped and informed by space science and astronomy in the past 40 years. Scientific understanding of the universe has been intertwined with culture since the time of Anaxagoras, and the popular imagination continues to be fueled by insights from space probes and large telescopes. What follows is not a survey of the many facilities that have furthered our understanding of the cosmos. Rather, it's an exploration of 12 iconic space missions that have opened new windows onto distant worlds. Most are in NASA's portfolio, but all have non-US investigators, as space science and astronomy have become increasingly international. In general, the arc of the book is chronological and moves from the proximate towards the remote. From comets to cosmology, from the Mars rover to the multiverse, these missions have given us a sense of our cosmic environment and have redefined what it means to be the temporary tenants of a small planet. The journey starts with Mars. 6 years to the day after humans left their first footprints on the moon, still the only world humans have ever visited in half a century of the space age. The first Viking lander touched down on Mars, with its twin reaching the opposite side of Mars 6 weeks later. The Vikings dashed hopes that Mars might be habitable, but they opened up the modern age of the exploration of the Red Planet. Nearly 3 decades later, another pair of intrepid machines bounced to a safe landing on their cushioning airbags. The Mars exploration rovers were embraced by the public as they trundled across the rocky red soil, inspecting interesting rocks, sending back pictures in 3D, and gathering evidence for a warmer and wetter Mars in the distant past. Mars may have hosted life in the past, and life might still be there in the underground aquifers, and it is this oscillation in the popular imagination between hostile and hospitable that makes it an uneasy doppelganger of the Earth. See, there's some things in chat. Newton's thought experiment. Oh, this is like the cannonball. I see. I'll show you guys that. Yeah, there's really no figures. Well, there's definitely no figures in the introduction, but it seems like this book is figure light. So we'll probably be looking at some things online. But yeah, so this is a figure of the shooting a cannonball. So what they meant by that, this one's from Einstein, it looks like, or this one's from Newton, I mean. Oh yeah, it's the same one. So this is just like a nicer digital version of the one he said he had. Stu McLeod said CND is gonna hit whoever fired the cannonball. Yeah. It's coming back. But yeah, it's just suggesting that with a certain trajectory, you can throw something and it'll start orbiting the Earth, right? With enough power and enough and the right trajectory, you can shoot something into space. And that's what we did. Thank you for that. Where was I? But yeah, this also, just to expand upon what I said, it's pretty there's not a lot of figures from what I've seen. There's some nice pictures, and I'll definitely show you guys the pictures, but it seems like it's not going to be a lot of figures. So another reason why this book is going to be dense. But we're going to get through it. It's very interesting. Oops, sorry. Okay. Where was I? Here we go. Oh, did the screen freeze? Oh, no. Oh. I think it might just be you, Lynn Jersey. I think we're still live. Yeah. Yeah, you might want to refresh. Sorry about that. Okay. I'm going to continue. All right. Next up are 2 spacecraft that made a grand tour of the outer solar system during the 1970s. Where before we had had nothing more than rough sketches, The Voyagers painted detailed portraits of the gas giant planets and their moons. These epic missions each ventured billions of miles from home, and they taxed the ingenuity of the scientists and engineers involved, many of whom aged and retired in the years between the first concept and its completion. The successor to the Voyagers was Cassini, which will soon enter its second decade of exploring the Saturn system. Cassini bristles with complex instruments, and it dwarfs its predecessors. Together, these three missions have recast our understanding of the frigid realm beyond the asteroid belt. Giant planets may be cold and miniature versions of the sun, but their moons are anything but dull and lifeless. Some have active geology and liquid water under their crusts. Others spew out sulfur or tiny ice particles. Many of them have distinct personalities, like the more familiar worlds in the inner solar system. The planets and moons of the solar system are intriguing enough to have earned the names of gods and mythological figures. Yet they are just sideshows in a process that concentrates most of the mass into a central sphere of glowing gas. The star is the central character in this drama, and the plotline is alchemy, the creation of the heavy elements that make up the planets and moons. Stardust was the mission that taught us not just one, but two comets by the tail. Nope, not taught. Sorry. Stardust was a mission that caught not just one, but two comets by the tail, and in doing so told us how the solar system was likely to have formed. The story of Stardust is our story, since most of our atoms were forged in the central cauldrons of long-dead stars. The solar and heliospheric observer, by contrast, focused on the sun itself and taught us what it means to live with a star. Belying its steady light, the sun leads an active life that manifests in invisible forms of radiation. Distant worlds will also have to deal with the vagaries of their nurturing stars. After that, we drop back to take in a view of the solar neighborhood from the unsung but impressive Hipparcos satellite. Hipparcos has refined the work of William Herschel over 200 years ago by placing us accurately within the city of stars we call the Milky Way. If the Copernican principle holds, the grit from stellar fusion that gathered to form the Earth is not unique to our region of space, and similar worlds have formed across the galaxy. The two missions that follow illustrate the revolution in astronomy, when astronomers' blinders were removed after centuries of learning about the universe through visible light. Spitzer and Chandra are two of NASA's great observatories, straddling the electromagnetic spectrum from waves hundreds of times longer to hundreds of times shorter than the eye can see. Each telescope looks at regions of space that are hidden from view. Spitzer penetrates the murk of gas and dust that permeates interstellar space and reveals new worlds being formed. Young stars and planets are shrouded in placental dust that is opaque to light, but nearly transparent to long infrared waves. This is a huge advantage when looking for exoplanets, because their contrast relative to the host star is hundreds of times better at infrared than at optical wavelengths. Chandra, by contrast, has revealed the violence of dark objects like neutron stars and black holes, where such tiny worlds distort space-time and accelerate particles beyond any capability of our best accelerators. We would be ignorant of all these phenomena without space-based telescopes. Closing the book are two missions that venture to the edges of space and time. The Hubble Space Telescope is the only space facility that has embedded itself deeply into the consciousness of the general public, to the level where the prospect of not servicing the telescope generated a backlash and an eventual reversal of NASA's original decision. Hubble has contributed to every area of astrophysics, but in particular, it has quantified the limits of our vision, a region spanning 46 billion light-years in any direction, which contains roughly 100 billion galaxies. The inferred 100,000 billion stars, with their attendant and similar number of habitable worlds, form the prodigious real estate of the observable universe, a census inconceivable to Anaxagoras and his colleagues. The Wilkinson microwave anisotropy? The Wilkinson microwave anisotropy probe was a specialist mission to map the microwave sky and pin down conditions in the infant universe. By gathering exquisitely precise data, this satellite has confirmed the Big Bang model in great detail. It has also shown that there are likely to be innumerable distant worlds out there whose light hasn't yet had time to reach us since the Big Bang. The journey ends with the near future, and efforts to measure realms of the universe that are currently at the edge of our vision. Close to home, the goal is to see whether Mars has hosted or could host life. Finding Life 2.0 would reset our views of biology beyond the home planet. In the proximate universe, we have the hope of detecting Earth clones and seeing if these worlds have had their atmospheres altered by a metabolism. At the frontier of cosmology, the hope is to test the multiverse concept, where the planets around 10 to the 23rd stars are just part of the story, and a suite of alternate universes may exist, with properties perhaps egregiously different or perhaps uncannily similar to our own. In this extreme version of Plenitude, everything that can happen has happened, and the set of events that led to our existence are neither special nor unique. That's the end of that section. I'm going to put that down for a sec. I hope everyone was able to get back on if you were having an issue before. Yeah, I think we're still running smooth. You never know these days. We're not going to have the PowerPoint problem anymore. That's what I am sure about, because I am going to find a different way to show you guys pictures. Oh, you're back. Okay, cool. Oh, that's the W map. Oh, okay. I was like, I've never heard of this before. What is this? That makes so much more sense. Because I know what the W map is. I'm getting lines on my face. I have the window open just slightly. But I guess that's too much. Oh, well. It's fine. Looks like we have another, page or so. So after that, we can just kind of hang out and chat for a little bit, because I would go on to the next section, but I kind of want to do it in chapters just in case people miss, then they know, they can, read chapter 2 and they'll be caught up or something, instead of, trying to figure out what page we ended on. And the next chapter is, 30 pages, and I'm not going to be able to get through that in another hour, so it'll be a short one today. Okay. Let's finish this off. The authors are grateful to the two Steves, Dick and Garber, from NASA's History Program Office for their careful attention to this project, and to NASA for financial support during the writing of the manuscript. We acknowledge Ingrid Gnerlich at Princeton University Press for her epic patience during the long and winding road that led to the completion of this project, and to the staff at the press for their assistance during production. Chris Impey is also grateful to the Aspen Center for Physics, which is supported by the National Science Foundation, for providing a congenial setting for substantial work on the manuscript in 2010 and 2011, and to his astronomy colleagues at the University of Arizona. Hey, that's me. I mean, not at the time, but it's me. For answering questions too numerous to count when he strayed from his expertise. Chris also acknowledges the hospitality of his colleagues in the Department of Astrophysical Sciences at Princeton University, where he finished work on the manuscript during an appointment as the Stanley Kelly Visiting Professor for Distinguished Teaching. I didn't know he taught at Princeton. We just need to sit down with Chris at some point and be like, okay, tell us all your crazy stories. Tell us all the places you worked. Tell us all the cool things you've done, because I never knew he worked at Princeton. Crazy. Anyway. We're going to continue. Holly Henry would like to especially thank NASA for supporting the project and the research. She also wishes to thank the administrators, faculty, and staff at the College of Arts and Letters, the Department of English, and the Office of Academic Research and Sponsored Programs, and the Pfau Library at the California State University, San Bernardino, for their assistance throughout the project. Holly is extremely grateful to the many colleagues, friends, and family members who discussed and recommended topics and sources. It has been a great pleasure to research and explore the breadth of ideas that inform the study and that affirm our deep connection to the universe around us. I didn't realize that was going to just be like a thank you. but I guess we heard it anyway. I think I may have lost some people with that. Okay, so that's the intro. It's a long intro. Einstein also taught at Princeton. Yeah, he sure is. I swear, the people that Chris has met and like hung out with, nuts, crazy. Like in all areas, like cosmology and astronomy and stuff. Like he knows everyone. But even stuff like like I've said, he's met the Dalai Lama. He's met a couple of the popes, 2 or 3 of them. He's hung out with Tibetan monks when he met the Dalai Lama. He went to... Sorry, there was a very loud noise on the other side of the wall. But he went to school with Brian May at some point of Queen fame. Because Brian May was an astrobiologist, or a physicist, astrophysicist. I'm not sure if he did biology or physics, but one of them. Cool stuff, yeah. But I think we're going to wrap it up there for today. I know it's a shorter one, and I know we just got through the intro, but hopefully that like hyped you guys up for next week. Oh yeah, we can talk about the table of contents. That's a great idea. So it looks like, according to this, all the missions that he listed, so both the actual like probes and orbiters and landers and stuff, and the space telescopes, those are all going to have an individual chapter dedicated to them. So we start with Viking, and then Mir, Voyager, Cassini, Stardust, Soho, Hipparcos, Spitzer, Chandra, Hubble Space Telescope, WMAP, and then a conclusion. And the conclusion is called New Horizons, New Worlds, so I think he'll probably also mention New Horizons. I'm not sure if they go into New Horizons very much, because New Horizons is a super important mission. I think it's super cool. Maybe I just think it's a super important mission because I wrote a paper on it once, but I love it. Also, I love Pluto. Sweet little Pluto. But this was the first time this was published. I'm not actually sure of 2010 maybe. This was published the first time I think in 2013, but the first paperback printing was 2016. So this book's actually from 2016. So they probably added some stuff about New Horizons. Because usually usually when a book is printed first in hardcover for like a science book, when they come out with the soft cover with paperback, they get a chance to update things. Thank you for the anonymous cheer. Look at that ghost dancing, so cute. Thank you so much. But yeah, so I don't know how much. I mean, it's like the Einstein's Monsters book, right? It happened to come out before the first picture of the black hole was taken. So that's obviously not in the book. So there might be things like that where it's like, it'll mention that like, this is the farthest we've gotten, and we've actually gotten a lot farther. We've done more research or something like that. Ooh, something like that. My question is, when it brings up James Webb, because it has to. They always have to. Every book about astronomy has to bring up James Webb, right? What will it say is its date to be launched? Because we all know that it did not get launched on time, even at all. A little, not even close. I think the first launch was the launch plan was in 2010. I remember I was editing, this is so off topic, but we're just chatting. But I remember I was editing some lecture videos, possibly lecture videos that you guys have seen, because I think it was the original course that Chris has on Coursera, and we were updating it because a lot of things, they made the course in the early 2010s, maybe earlier than that, maybe like 2008 or something, I'm not sure, but it was early, and a lot of it had to be updated because a lot of things have changed, and I was editing it last year, and found that it said that the James Webb was going to be launched in like 2012 or 2013. Chris is like, we're expecting it to launch in like 2012 or 2013, and that had already been pushed back or something. I don't know. I might have the dates wrong, but it was like, it was pretty funny because I'm sitting there editing in, 2020, and I'm like, well, that hasn't happened yet. But hopefully soon. But yeah, I think we will wrap it up there. Hopefully this also, since we just did the introduction this week, it'll give people time if you guys want to get the book in some way. Obviously it's on like Amazon and other international sellers like Amazon. But there are also cool websites, like see if you can try to find it through local bookstores maybe. I know a lot of local bookstores will have like connection to this other like database for small independent booksellers that they can order like pretty much any book. We could do ultra short autobiographies someday of less reading. Oh, that sounds fun. That sounds very cute. I like that idea, Student McLeod. I'll have to, yeah. That would be fun. Either at some point, yeah, maybe during book chat or maybe as one of our Wednesday streams, we could do that. And I'll just kind of introduce ourselves to each other because we have a very tight-knit kind of TeachAstronomy family here of the people who like pretty much come every week when you guys can, and that'd be cool. Single coded, you remember the reading the content about James Webb, and then yeah. You're like, wait, when did that, I don't think that launched. Yeah, no, it's now I want to look up when was James Webb, when was the first time it was supposed to launch. Let's see. Well, not NASA, you're not gonna tell us. You're gonna be like, and you might have launched it later. Let's see. There must be a delay thing. Oh, come on, tell me. Background development. Cost and schedule issues. There we go. Oh my god. Yeah, it was planned to launch in 2007 when they started working on it in 1997. I think it was just like the plans to work on it in 1997. I don't know when they actually started building it. And then it got pushed and pushed and pushed. And now it is October 2021. I know, it's taken a long time. I mean, they had ideas to launch this thing. They wanted this thing. People were starting to work on proposals and stuff for this thing. Like right around the time that Hubble had launched. Like I think it was before the issues with the Hubble mirror and everything. Because they already knew like we're going to need a successor to this. And it's taken a very long time. So it's a good thing that Hubble was fixed and has lasted so long because we haven't had another telescope to replace it. But I was going to say that the Dreams of Other Worlds is... Oh, there's an audiobook version. Again, it's like it's supporting Amazon, and I don't like Amazon, so... But there's an audiobook version for like $10 through Audible. Or I know a lot of libraries, at least in the United States, but I'm sure overseas as well, have subscriptions for their library users where you guys can get like audiobooks. I mean, I guess if you're listening to me, that's kind of the audiobook. Why am I suggesting an audiobook? I'm your audiobook. Forget everything I just said. Don't go listen to somebody else. Listen to me. Listen to me struggle through the names. Have a good time here. But if you want to follow along and like read it, which is what I meant to say, they've got it on Kindle and you can buy it and stuff. But you can also try to if your library doesn't have it, if your local library doesn't have it, usually you can like request. At least in the US, you can request and they could try to get it for you. That's how I got one of Chris's books into the Tucson library system, because somehow it wasn't there. It was the science fiction novel. So sneaky like that. Anyway, I think that is where we are going to end it today, unless anybody else has questions on things before we go. But some housekeeping stuff really quick. If you haven't yet, please follow us so you know when the next time we go live will be, and so you don't miss any of our book streams. We also, for the rest of this week, we will have astronomy, either astronomy news chat or astronomy something chat on Wednesday with Michael, and then amateur astronomy on Friday with Matthew. And then, next week here, same time. We also I think we're going to be doing some sort of gaming stream, because I really want to play this game on stream called Outer Wilds. And it is a beautiful game that I have played like an hour of, and I want an excuse to play more. So it'll probably be happening over the weekend. We'll give you more information in the next couple streams and through Discord and stuff. If you guys want to be there for that, it should be a really fun time. It's a game all about like this alien, you're like part of this little alien race that's very much it's an alternative to steampunk, in which like it's almost like wooden punk, because like all these their spaceships are made out of like wood, and they can explore the stars, but it's very like rickety kind of star exploration thing, but it's cool. So if you want to join for that, that'll be probably on Saturday at some point. Next stream will be at Wednesday at 11. Is it 11? It is 11, because I thought it was 10 last week. I just want to make sure. Yes, it is at 11 a.m. Pacific Standard Time. That is on the schedule. And also, I just realized Matthew gave me date for Chris's next stream, and it's coming up. So let me tell you guys really quick, and I will put it on the schedule in a little bit. Also, just a reminder, we are Twitch affiliates, so as Anonymous Cheer showed you, you can cheer bits. You can also subscribe to us. It helps out the channel a whole bunch. Helps us keep bringing you guys this content. And then our next live session with Chris is actually going to be immediately after our Wednesday session. So Wednesday's stream will be the precursor to Chris's stream, so I'll probably end that a little early so I can get stuff set up with Chris. So yeah, you can hang out. And Friday is at 10 a.m. And I think that is everything. So I will see you guys all on Wednesday, I guess. Thank you all for being here, and have a great day.